I'm Dan Drews. I'm going to talk about how to automate PR reviews using external services and Azure within Azure DevOps. Yeah, gonna dig into that. So just quick introduction to myself. Like I said, I'm Dan Drews, full stack developer at Buildertrend. Been here for, it'll be 7 years in March. And really, again, I work on the full stack stuff, not really the SRE stuff. So this is a little bit out of my norm, but found it as an interesting topic, figured I'd share it. So let's dive in. So just in general, what is this? This is the ability to essentially have a service that can either reject or approve pull requests as they come in based on, essentially analyzing what they are. So really the way it works is you have a webhook that when a new pull request comes in, it'll post to that webhook. When an existing pull request is updated, it'll post to that webhook. Well, separate webhooks, but same type of thing. And then really your code can go do what it needs to do. Once it finishes processing, determines whether it's passed or failed, it will do an HTTP post, just shoot back to Azure DevOps saying failed or succeeded. And then until it succeeds, you can mark it as required. So even if somebody approves it and starts to complete it, it'll be blocked from actually merging. So it's the same thing as if you were doing just, using the built-in build pipelines within Azure DevOps, but this allows you to call out to external tools to do it. This is not a unique concept, to be clear. GitHub has similar things. And just with the few open source projects I've worked on GitHub, most of them seem to utilize this to some degree. So it's not unique to Azure DevOps, but I'm talking about it in that context. And really just what's the purpose of it? So you can automate trivial checks. There's several goals. And one of those is that I find enticing is just automating trivial but necessary processes, really freeing up the code reviewers to focus on the items that are important rather than the stuff that they don't really need to focus on. Doing so helps also avoid mistakes that could end up costing a significant amount of time later on to correct. And then lastly, the webhooks portion of this can allow for integration and synchronization with third parties. So I'll touch on both or all of those here real quick. So a few sample use cases that we have. This first one isn't actually as necessary anymore. Azure DevOps built in a draft PR concept that wasn't there a few versions back. But this is kind of a sample that Microsoft has, which is you can set the title of a PR to start with WIP, and if it sees that, it'll prevent a merge. So if I'm sending over this PR for code review to somebody just to take a look at it when it's not ready, they don't have to think, oh, is this a work in progress or is this ready to go? They can click approve and it still won't merge until this hook gives the thumbs up to do so. Another example is third-party license review. So there's a number of automated processes that can be used to evaluate all the licenses of third-party and open source software to make sure that it's a specific open source license that your legal team has approved, make sure you have licenses for these pieces of software, and you could kick off a service that'll go analyze all of your packages, your package config, your packages.json, all of those things, and make sure you're good to go there, and just block the PR from merging if there's any red flags. The next example, which is one that I'll dive into in my example, is naming conventions for pull requests. So in our example, we use a custom ticketing system called BT Projects, and we tie our pull requests to our tickets simply by prefixing it with BT and then the ticket number. So this is a tool that can actually go out and validate that it's named properly, just a simple thing like that. And then additionally, you could go sync that ticket up, and you can use the webhook and call into BT Projects and tie up these pull requests and tickets together just to keep them in sync. Another example is code analysis. So MS Build has really great built-in code analyzers. They have a huge suite of analyzers you can run. You can build your own pretty simply, but that only works for things that use MS Build. So let's say you want to run code analysis outside of your build pipeline on something like TypeScript, because ESLint may not have the level of analysis natively that you want for your TypeScript build. You could go ahead and essentially kick off something that'll download all of your code. It'll pull the repo and run an external tool, and then post back up and say we're good to go. So an example of that is SonarQube, which uses that same type of concept to be able to, you can post over there, it'll essentially run its analysis on your code and kick it back over and mark it as good. And then another one that I think is quite interesting, if you've ever contributed to any of the projects maintained by the .NET Foundation, they use GitHub, but it's the same concept. They actually require you to sign a contributor agreement to release the code prior to approving it. So they have essentially a hook that when a new pull request comes in, it'll validate that a user has signed that agreement and block you from merging that code until they have. So those are just some sample use cases, but I'm sure there are hundreds more that I was not able to think of there. So how do you go about doing this? So to get started, and this is the steps I took, I set it up as a personal access token, but first we need to essentially just get access to use the API. So I think you can set it up as an application, but the easiest way to get up and running was I just generated a personal access token that had permission to, under code, to read the code, read the pull requests, and then write status. So it's just those two ticks that are there. So that's the first step. So that's to get to the personal access token, you click on the little settings icon next to your name and go down to personal access tokens. Excuse me. And those are actually tied to the user who generates it. Up next, you need to create a service hook. So this is the webhook that notifies your service of the new pull request. So to get there, within Azure DevOps, in the bottom left corner when you're on a project, there's a project settings button. So you go to project settings, you go to service hooks, and then you add a new webhook, and you add one for both new pull requests and pull request updated. And then one quick note here, the URL that you use will obviously need to be public, or if you're using the on-premise version of Azure DevOps, it'll have to be accessible within your firewall for that. If you need it to be public, you can, just if you're at home, you can use port forwarding, or you can use ngrok or local tunnel or other tools like that that will help expose your service to the outside world. So then you just provide the URL and give it a test. Now, there are libraries you can utilize. I was having a hard time figuring out which NuGet package I needed to use specifically in order to just automate to utilize the libraries for it, but it's all just simple REST calls too. So when you hit test, it'll post a sample JSON payload to your endpoint that you can use to build your classes. So the last step that you need to do is set up a PR policy. Now, you've probably done this before when it comes to setting up your policy, saying you need X number of reviewers when you're pulling into master, that type of thing. So you go to that same place. So you go to your list of branches, you click on master, and you click the little security badge. And then if you scroll down, you'll see a add a new status check button, and you can provide the name of the status and then mark it as required. So if it's marked as required, it will block the merge if it's not ready to go, or if it's not marked as success. So I'm not going to walk you through all of those pieces, but I will kind of walk you through the demo and what it looks like. So I've got a code demo out there available, and I will post this link in the chat in case anybody would like to download that and follow along. But I'll just kind of get started here. So over on the right here, I have my my Azure DevOps repo that has a branch in it with just the finishing touches of what I was working on for this sample. So I'm going to create a new pull request, and over on the left here is my code running just to demo it. So I'm going to go ahead and just call this pull request finishing touches and create it. And then in a few seconds, we should see a webhook come into this breakpoint to validate it. So you can see over here, we have this continuous integration / ticket number. That's the check that still has to run. So over here, the post body just came through, and we can see all kinds of things on there. We have the ID, we have resource information. There's all kinds of things that's posted over. All we care about specifically is the resource and the title, and that's just finishing touches. So again, I'm validating that the pull request that's sent over essentially just starts with BT dash, then some number, and then the title right there. So I can go in, oops. All right, there we go. So I can just use a simple regex to validate that, that this title matches. So we know that it does not, because the title is finishing touches, which does not start with BT and a number. So, and it's actually got 2 threads of this going now because it didn't respawn quick enough because of my breakpoints, but it doesn't match. So we post up to the server saying, hey, this failed. And if I just run through this, you can see that over here, it marked it as failed. So if I were to approve this, it still just wouldn't approve it because there's still checks to run. I can set autocomplete, all this stuff. It's not going to go because it's blocked by this. So if I come up here then and change this to BT-123 finishing touches and save the title, we'll see that the pull request updated hook will get called. So once that comes through, it looks like there were a few queued up. So here we go. We have 1, 2, 3 finishing touches. So we'll validate. The regex will match this time, so we'll mark it as succeed. And if you watch over here, this will just flip over to green and good to go. And it is getting called a lot out of order, I think, because of my breakpoints. Wow. Oh, it's merging it now, so that's calling additional hooks. So my breakpoints made that all kind of go through out of order, but the check succeeded, and it is merging the pull request. So that's just a basic sample. If we were to look in here at what this set PR status is, really we get the URL as part of the object that calls in, and then we have what's called an iteration. So an iteration is each time the code is pushed. So if you're, say, running code analysis on the actual code base, you can track per iteration whether that succeeded or failed. And you're actually required to, because we have it reset when new code is pushed, publish the status to the iteration. And then we just include our access token. We publish the description and the name for the check, and it's good to go. So yeah, that's pretty much what we're dealing with. This one is quite simple. Like I said, you can get to a very complex setup here if you choose to, but this is just a simple thing that, you know, takes my mind as the code reviewer off of having to worry about, did they name their ticket right? You know, those little trivial things. So with that, I'll open the floor to any questions, or if anyone has suggestions of where else this could be used that could maybe help others, that'd be great too.
Yeah, I think you covered it a little bit there. But there was a question that had about detailed response message, details about what happened inside of Azure.
Yes, I'm pretty sure you are able to post details about why it failed. Additionally, that's not something that I saw, but I'm fairly certain that you are able to do that. I see another question about whether there's a timeout value. I don't think so. What you may have seen at first is it was just spinning, saying waiting to receive this. So I believe it'll just sit there spinning, just not moving on until it receives a value being posted to it. Because now I showed you the webhook. This, you know, you could kick off a long asynchronous process for that. The webhook's not necessarily directly tied to the response. Like, I don't respond to this with success or failure. This could be an asynchronous thing. There's no response coming back from my webhook other than a 200, but there's no real response coming. So it could kick off a completely asynchronous process and respond to that. So the webhook is just how your policy knows about the new pull request.
You used a personal access token to set that up. What
Yeah.
happens if you're no longer with the company and your account's disabled?
Yeah, like I said, I used a personal access token. I think there's a way to set it up as an application that has rights to run and do that thing. I was just looking at the quick start method, but they have ways of setting up applications that can interact with TFS as well, or Azure DevOps. So, because yeah, that access token, I think the longest you can set it for is a year before it expires as well. So, yeah, it's not a permanent long-term solution. All right, cool. If there are no more questions, then I will go ahead and kick it over to Derek, who's going to talk about utilizing TypeScript and Storybook. So go ahead, Derek, and take it away.
All right. Thanks, Dan. That's
cool.
pretty good. Let me share my screen real quick. All right. I think I got this going. All right. Hi, everyone. My name is Derek Batenhorst. I work for Buildertrend. I have been at Buildertrend for about 2 years, and I'm currently working on the architecture team. Today, I'm going to talk about the API layer on the front end and how we use TypeScript and Storybook to help us kind of make that a more type-safe area for our application. I'm sure most, if not all of you, are familiar with TypeScript. It's a very wonderful tool for that allows you to write front-end code in a type-safe way, and it's very helpful for large front-end applications. Now, the API layer is traditionally one of the most untype-safe areas in the application, and a couple of reasons for that are because it's you have a low return on investment to map that area. And second of all, the API layer, the two responsibilities it has is hitting the server to fetch your data from the server. And the next responsibility is it takes that data from the server, and first thing you do with TypeScript is map it to a type-safe object, be it a class or interface. So because of that, the API layer there's a low return on investment to create additional types to type your server data to it, because you're just going to map it to a type-safe object anyway. So it doesn't really make sense in a lot of cases to create an extra layer of types. So that's, for a lot of reasons, that's why it's untype safe. So before I begin, I'm going to go talk about a tool we use at Buildertrend called Storybook. Some of you may be familiar with, but I'm going to go ahead and go over it for everyone else. So what Storybook is, it's a front-end tool for your componentized system. So that means if you use React, Angular, Vue, Svelte, there's another other one I recently heard about. And it's not limited to those. You can use older libraries like Knockout. You can make components. I suppose if you wrote your code and architected in such a way, you could probably create jQuery components. What I'm really trying to get at here is that Storybook is really framework agnostic. You can basically throw anything in there and it'll just run it. It's a great tool for creating your components in isolation. So what I mean by that is when you start creating a component for your application, you can start developing it in Storybook and it kind of iterate on that until it's looking right and behaving the way you want it. And then you can throw it in your application, and when it's in your application, if everything looks good and acts fine, then you're good. But when it looks different than what it looks like in Storybook, then you know there's probably some external style or something kind of interfering with your component. So it's a good way to kind of track those things down right away. Another useful thing about Storybook is it's a way to document your use cases for a component. So yeah, part of those use cases you have, your hard to reach states. And you can also use the stories as kind of visual unit tests. So when I say hard to reach states, so think of an example where you might have a certain type of user. So your system might have multiple types of users. You have to be a specific type, and that user might have to take specific actions in order to show a component or show a component in a certain state. So instead of having QA or someone else replicate exactly what you've done in your setup, you could just throw that component state in Storybook and just say, hey, go to this story and you will see this component looking this way. And that's a great way to also kind of visually unit test your component, and which is very good if you're making like global style changes, like maybe a front end widget upgrade. So say you have a large library like Kendo, Telerx Kendo library. If you're trying to update that, it's going to touch a lot of components. So you can make the update and just run through all of your storage and kind of see how it affects all your components. If you want to learn more, I included a link to Storybook in the slide, and I can post my slides in the chat, so it's available, but URL's right there. So this example, I wanted to include this, so if you've never seen Storybook, you kind of have a visual representation of what it looks like on when you run it. This is from their website, so nothing that I created. On the left, you see the stories organized by functionality and then components. And then on the right, you see the component, how it's rendering. So in this example, it looks like they have a charts area, and then you see 4 components underneath that: the line graph, pie chart, spark, histogram. And then in this example, they have histogram. The histogram component expanded, and I see 3 stories underneath that. So you got the default case, which is just, hey, here's my component. The empty case, here's what it looks like with no data. And then normalize, which I can only guess that means they're probably taking the data and kind of normalizing it. But looks like those are 3 use cases that this component supports. So that's Storybook. Now, when creating a story in a componentized system, you got to kind of realize you could take your components and kind of break them down into 2 basic types. You have your presentational components and what I like to call a self-loading component. Presentational component is a component that can't load itself. Basically, all the data it needs is being provided to it via props or some sort of input. Whereas a self-loading component might be provided like an ID or little pieces of information, but it's for the most part going to load the data for itself. So most likely this type of component will, once it's loaded in the DOM, it will go ahead and make a request to the server to load some data. So that's kind of important to know, because when setting up Storybook, like I said, one of the goals here is to develop your components in isolation. And just like your unit tests also run in isolation. You have to mock things. So in order for us to run stories for a self-loading component, we have to mock our API handlers. We call our objects that interact with the server handlers. I've heard them called services. There's probably a lot of names for this, but if you hear me say API handler, that means that an object that's gonna fetch data from the server for us. So when we go to mock these API handlers, we all these are really doing is loading data from a JSON file. And the data that's in the JSON file represents real API calls. So for the last 1.5 to 2 years or so, we've here at Buildertrend have been in the middle of a React rewrite, and one of the benefits we've had is the Buildertrend application had 2 mobile applications that we support, you know, an Android and iOS application. So to support those, we already had this API built out. So when we were going to rewrite a new page, we would kind of target the endpoints needed to load all the data for our page and kind of identify those, actually hit them in real life, take the data that we got that was returned and just throw it in a JSON file. And then we reuse those JSON files in our mocked API handlers. So we kind of had real data to work with when we started our stories. So this is an example of one of our stories. It's kind of your basic contacts page. This is an example of a self-loading component. It's our contacts detail page, which when it loads, it's going to hit the API to pull up contact information for a specific contact or customer. So it has your basic data like your name, address, phone number, email, and that sort of thing. So the storybook example for this kind of looks like this. So as you see here, we're stuck on an older version of Storybook. If you've seen Storybook 6, the syntax for creating a story is slightly different, but same concept basically. So in this example, you can see here our fake handler. So this is that object that's responsible for fetching the data from the server. So first thing we do is we create this new class. It implements this contact handler class. So the real API handler actually also implements this, of course. That's how you mock things. So first thing we do, so like I said, we're doing a React conversion, so we're returning React in this story. So down here, we have this contact component. First thing we do is we set the handler on that. We pass in this fake contact handler, which is this one right here. And what's going to happen in this component when component did mount happens, so when the component is loaded in the DOM, it's going to make a GET request to fetch the data for it. And you see we're passing in an ID. That ID is going to be passed into this GET function right here, which returns a promise of contact entity. So all this fake is doing is returning a resolved promise, and we're just newing up a contact entity, passing it this data. This contact API response actually represents our JSON data. It's the data from that JSON file. And you can kind of ignore this address field, where I think what's happening here is we are kind of setting up the data in a slightly different way for this use case on this component. But yeah, that's all you really need to know for that. So like I said, the second thing that happens in the API layer is the data is going to be mapped right away. So as you see here, because we don't know the shape of the data, or TypeScript doesn't, we have no types defined, we're not getting types from the server. We basically have to type this as any, meaning we're basically telling TypeScript, hey, we know what this object is, don't throw any errors for us. So, you know, you can kind of see the names over here on the left match what's on the right. That's common pattern. But you can kind of start to see that we have to know certain things about our data that we're getting back from the server. Like, for instance, this has to be a moment object. We use moment for our date times. So we have to basically convert this string to a moment. Down here, you can see that first and last name, these are not strings. They're actually objects, with a field called value. So that's how we're loading that. So there are some problems with data as any, because what will happen if you do make a mistake here, the TypeScript was not going to help you out because you already told TypeScript you know what this type is. The issues are actually going to happen at runtime when you actually run the application. So number of things can cause this: misspelled properties, incorrect data types, or a scenario where data might be returned for multiple use cases. So think of, hey, this endpoint returns this data in this shape where we might be missing these 4 fields. In this other use case, they actually exist. So in the case where they're undefined, if we don't mark it in our class that it's undefined, then we could get an exception where we're trying to call something on undefined. So here's that previous example with some errors I introduced in it, but because data is typed as any, we're not seeing them in our IDE or Visual Code in this case. So as you can kind of see here, I listed out what I've done: mistyped, created by, created dates, not a moment. This can send SMS is really a Boolean, but we're checking it against a string. And the first and last name are actually objects and not strings. So how do we fix this problem? Or what can we use to help us in this area? One thing we've kind of figured out is, since we've created all these stories for all of our components, and we have all these JSON files that we're maintaining for our stories, why not just import them and infer the type? We'll let TypeScript infer the type from those JSON objects. So in this example right here, we are importing that JSON file, and we're using this type keyword, which is nice. Might not be needed, but it kind of helps us from accidentally including this entire JSON file in our production code. What this is actually doing is telling TypeScript that, hey, I don't want to use the actual object here. I'm only specifically using this for types. So if you try to use a concrete version of this, TypeScript will actually yell at you because we're using this type keyword. So that's a great feature to prevent accidental, to prevent this JSON file from being included in your bundles. Next thing we're doing is, this is the step where we're telling TypeScript to infer the type of the JSON object. So we're just simply using type of and assigning it to this type. And then the next step is, we are using this type and saying data should be of this shape. And now all of a sudden we get all these red squigglies. It sees the create by doesn't exist on data. Created date should be a moment object. It's really a string because that's all the server can give us. Can send SMS is a Boolean. It's not a string, so.
No, don't splash. Okay, can you go?
So sorry. So that's wrong. First and last name are not strings. This is actually an object, and the infer type will see that it's an object. So some other problems that this helps solve, and actually one of the reasons we thought of this as a strategy, is that our mock storybook data gets stale over time. So what we kind of find happening is a developer might go and create a new component and create the stories for it and kind of iterate off of that, getting things looking good and behaving fine. And after it's all QA'd, it goes to production. And then over time, we might need to add in a new feature or fix a bug in that component. This next developer that might work on it might not run Storybook, but only run this in the application and check it there. And so in this case, our Storybook data is getting neglected. So then our Storybook breaks. So some changes that they might be doing that might break our Storybook build is in that mapping layer, they might be accessing a new property or changing the name of a property or changing the type of a property. Those are just some examples of things that can break that story just by little changes in that mapping layer. So this kind of helps solve that problem. So is this a silver bullet solution? Like everything, I haven't said anything bad about it. It must all be good, right? Well, not so fast. There are some drawbacks to it. This won't work in all cases. It works, I'd say, in a majority of cases, but some of the problems with this is that if you need to support like union types in an object, say you have a property that can be undefined in some cases and not in others, you need to create at least 2 sets of JSON files and then union the inferred types. So let's say you have a property that can be a string or it can be undefined. Well, if you only have one file, it's either going to be undefined there or it's going to be a string. If you want TypeScript to know that it can be both, you need at least 2 files with each one having undefined and one having a string in it. Union those together, now TypeScript knows that it can be undefined. So that's fine and all. Unioning types isn't a hard thing in TypeScript. The problem comes when you start having type complexities and you start unioning types of complex objects. I had the second example I ran into the other day where I had my mock data contained a property that was an array of objects, and each of these objects were driven by a field, would kind of change the shape of the object a little bit. So I listed a couple examples of this. So let's say an object had a type property that when equaled currency, value was actually an object that contained the value in like units of precision, and another entry when type was string, then value was simply just a string. So I had a real hard time unioning those together and basically ended up abandoning this approach because it really wasn't worth the investment of trying to fit this in. So like a silver bullet solution, but it works in a lot of places. So that's all I had. Does anyone have any questions?
Haven't seen anything in the chat. Any questions for Derek before we move on?
Have you thought about or looked into using like anything like Open API to generate those type definitions for you?
No, we haven't. All right. Well, yeah, I'm not seeing any questions, so I guess I'll kick this over to Stephen.
Yeah, thanks
Thanks,
Derek.
everyone.
Yeah, thank you. It's good.
Hi, my name's Steven Slater. I've been a developer at Buildertrend for just a little bit over a month at this point, but I've been in software development for a long time. And what I am going to be discussing is dynamic content registration using reflection. So the AutoMagic code that everybody loves. Excuse me, sorry. So one of the big problems that people commonly have is with large systems, you can have a lot of different assemblies with many different types, and that can create a lot of problems with assembly references, type references. It can create very complicated builds, and where you have build orders that are not very well documented, they can become out of date or overly restrictive when you want to try and make changes to the system. And of course, you can end up with the dreaded circular references where you have assemblies that end up referencing each other that can cause all kinds of problems when you start trying to build your application. I guess before we continue, or do we have a hard stop right at 7?
No.
Okay.
Nope.
Okay.
I think 7:30 would be your hard stop.
Oh, okay. All right. Well, great. I will definitely be done by then.
Okay.
All right. Thank you. So one possible solution, as Derek just mentioned, this is not a solution for everything, but one possible solution is to create a system where content can be self-registered when the application starts. It uses .NET Reflection. The basic logic is implemented in the core of the system, and then the other content can be defined anywhere else in the system. So the individual use cases for this would be your plugin based systems where you have applications that have objects that are vastly different in their use but can be constructed in a similar and predictable manner. It would be good for adding things such as the handlers, services, managers, or other objects that are used similarly throughout a system but have wildly different functionality. It can be used for user or client-based installs, where you have feature-based assemblies that can be created and feature-specific code that can be localized to a single assembly. Your system can then have unique features based on the assemblies that are installed and based on the assemblies that are in the application directory when the application starts. And then you can implement all manner of databases, logging, UI constructs, and business logic as desired within the specific implementation. And then the last part is the highly configurable systems where you can tie this sort of system with some sort of configuration setting. Can be based on registration name strings, which is one of the nice things. So rather than hard registering a system type or using an assembly name, you can just use strings to register these individual types. So it reduces the problems with breaking changes because you're changing the type names, changing their references, locations, getting rid of deprecated features. Those kinds of issues can be more gracefully handled because you're going to be trying to get this object based off of a name. If it returns a null, then you can just simply provide an error message rather than having some funky type registration issue or type handling issue. And then you can combine this with feature flags or other configuration settings to customize your content as an extra layer on top of that. So how it works from a high level is you have your main program code that it's a very small amount of code that runs when the system starts. It loads up all of the types that are registered from all the assemblies in the system, and it creates a series of processors. Each of those processors then have all of the types passed to them, where then they filter out the types that they are not interested in. Once they've done the filtration, then they pass on their valid types to some manager or helper class that can then handle those objects as necessary. So here's a little bit of pseudocode. So the first pass, you're going to load all of the assemblies, you're going to get all of the types, and you're going to check for this dynamic content processor base type. So all of your processors are going to inherit from this one type of class. When it finds an object that inherits from it, it's going to create an instance of it, and it's going to add it to a list or a map. Then in the second pass, it's going to go through all the types again, and it's going to take that type and throw it towards each of the individual processors. So you have, for example, then you have a base class for all of your dynamic content items, and I'll go over how it all fits together later. You have your base class for your dynamic content, where you specify, for example, an output type, where you just have some basic public functions. It would be an interface equivalent, where then you can implement some overrides for it. You have your manager or helper class, where the registration of that dynamic content is going to happen. So you can register the output type based on a name, where you're passing in the type. And then you have some public functions saying, hey, I want to send this message to the output. I want to initialize and uninitialize the output to do some custom content. You have an attribute, and this is really the glue of how it works, is that all of these dynamic content items, they have an attribute on them which the individual processors will look for. When it finds that attribute, then it will know to add this type to a manager or helper class. So as an example, we have an output processor which inherits from our dynamic content processor here. So it is looking for the register output attribute on those classes. And if it doesn't exist, it will just skip out, and it will output the register the output type, excuse me, with that output manager. So then we implement a specific output type, which is going to output information to the console. You can see the initialize and the uninitialize. They don't do anything. They just write lines to the console. And then same thing with the output text. It will write lines to the console. You can then create other types of output. You can create one that registers to a database, where the initialize would connect to the database, the uninitialize would close the connection. You can create a file-based one where the output, the uninitialized, can actually write the contents to the file, whereas the output text string can build up a list of content that needs to be outputted. This can be used for almost any kind of content that you want. The benefits of it are you can create a more streamlined code set where you can significantly reduce the need for hard assembly references. The only time you need a specific assembly reference is when you want to use that code in your class. You can create far fewer circular dependencies. Your closely related code can be moved into a specific isolated assembly, and this goes back to those feature-based assemblies. So if you have a connection type that is specific for Postgres databases, then you can create an assembly specific for your Postgres SQL connections. Whereas if you have one for file-based, then you can create one for Windows file-based, one for iOS file-based. Your assemblies can also then be broken up into core and ancillary assemblies. So you have your core code that can exist in one repository, and then your auxiliary code or your ancillary code can exist in another one. They are not core to your system, but they can be customized based on feature, based on client, based on the tier of product that the customer has bought, any number of other criteria. It's great for plug-and-play systems where you can easily enhance a system without changing the core code. You can register another type of dynamic content and then create dynamic content with a registration attribute that will then automatically be registered the next time the application starts. Your content and features can be temporarily disabled very easily by just simply commenting out an attribute on a class. And I can show you how that works in a little bit. And you can define many different processors to handle all manner of dynamic content. So that way you don't have to be constrained with a single method of registering all of your different classes, services, assemblies. And then it also allows you to create a lot more black box code where the specific implementations for various features can be abstracted away, and your new implementations can be easily added, replace old ones when desired. Now, as with everything, there are drawbacks. One of the biggest drawbacks is, well, it is magic code, so you end up getting a lot of questions dealing with how does this work? You know, where do these items get registered from? How is this code executed? And what's more, you end up with a lot of problems saying, well, hey, why isn't this one class getting registered? Your developers, the team that you're working with, needs to have a lot of proprietary knowledge with this system, at least understanding how the basics of this system works. And without good logging or documentation, it can take some time to troubleshoot the code. One of the most common culprits is when your assembly output is not pointed to your application directory where you're starting the application from. Then obviously nothing in that assembly will be registered. So then you can spend a lot of time working on something and then it doesn't show up because you didn't point it to the right directory. The other big problem is decentralized code, where you can result in a whole lot of small assemblies. Sometimes that's a good thing, other times it's a bad thing. You can end up spending a lot of time working on project settings and making sure that everything is configured consistently. There's also no common place for registration names for those strings that are used to register items. So the possibility for name collision or type overwriting does exist if you're not careful. So if you have a database connection type and somebody else creates a similar database connection type that works completely differently depending on your implementation, one could override the other, or you could end up with an error message where one doesn't get registered. And then with decentralized code, you can end up having multiple features, multiple classes could end up doing much the same thing, and you would never know it because they're in two completely separate assemblies written by two completely separate people or by separate teams, and they hadn't talked to each other. And then, as I mentioned before, because you can create a core and ancillary system, it can result in a 2+ tier system where it complicates the build process, where you have core code and then the ancillary code. It can make things more complicated. One other disadvantage, potentially, although this is relatively small, is that because you are iterating through all the assemblies and all of the types at startup, there is a performance penalty when the application first starts. Now, I've used this in one place where I worked, where we had dozens of different processors and thousands of different types, and the performance penalty on the server startup was maybe half a second or slightly more than that. So as an example, on here, I created the console output, as you saw, where we are just writing the output to the message to the console. I also created a file output where the information is being added to a list, and then at the end a file is being created and everything's being written to that file. So if I were to run this, you can see I have my output initialization for the console of all of these different types, where the individual types, I have some 2D shapes and I have some 3D shapes that have their individual properties being outputted to all of the individual output types. If I were to come into my configuration manager, you'll see I don't have a file output. The file output is not being registered. So the program output.file output was not being created. This is actually a much older copy. But if I were to add that to the configuration, rebuild everything, then when I start it again, the application runs, and you'll see now I have a file output that is outputting the exact same information. Likewise, if I were to come back in here, and go back into the configuration manager and take out the 3D shapes, clean the solution, rebuild it, and run it, and now it's going to make me a liar. I apologize, because the 3D shapes were still in there. You can see that it didn't clean those files, but if I just delete that and then start without debugging, now you'll see the 3D shapes are no longer in the output because they were not dynamically registered with the system. So with all of these individual shapes, you'll see that the circle, for example, it just has an attribute on it saying, hey, I want to register the shape as the name of a circle, and then the base class knows to register those. It has the register the shape type in the shape processor. So we have the shape processor class, where when the types are passed in, if it's not a shape, if it doesn't have a shape attribute, it's going to ignore it. It's going to get the name of the shape, and it's going to register the shape with the base shape class, which is just keeping a dictionary of strings and their individual types. And then once the application executes, then it is going to simply go through and call output content for everything, which is going to call output content for all of the shapes, which is then going to fire it to all of the individual output types. A previous place that I did this for, we used it for registering plugins. We used it for registering UI content, different types of UIs, so text editors, drop-down lists, indicator lights, multi-text selection, free text fields. We used it for registering services and all manner of other content, all without any of the base classes having to know about it. The services were especially nice, because then what could happen is all of those services could be registered with a core service manager that was defined at the heart of the system, but then only the individual assemblies needed to know about the specific implementation of the service. They could get a service based on its registered name. They could then cast that service as a specific type or specific interface and then use that service, nobody else knew or cared what that service was actually defined as. So it helps replace some of those for those Lord of the Rings people, those one class to rule them all kind of classes, where you end up having a single class, single assembly that has references to dozens, if not hundreds of other assemblies, and then it has to reference every single object from those assemblies that are similar. Are there any other questions? Are there any questions? And I do have, at the end, I do have a GitHub project where everybody can look at. I will add that to the chat so that way everybody can look at it.
Stephen, it looks like there's a question in the chat. Couple questions now.
Yep. Well, the nice thing is, protected and sealed, because the nice thing with this is that a lot of these objects, they can actually be protected because they do not, because it's the assembly itself that has scope to it. So when you're getting the assembly, you're getting the types for that assembly. Sealed, I mean, using the sealed, it basically just prevents other classes from overwriting it. So you can use it if you want. You only need to use sealed if you don't want anybody else inheriting from that class, right?
A lot of times those are compiler rules, right? That don't necessarily apply to reflection.
That's right. Yes.
So it looks like the other question was related to
Yeah.
how the objects get treated as they're dynamically loaded.
Well, I mean, most of one of the nice things with these processors is that you can treat objects, you can do a lot of customization on those processors. So you can, on the processors, you can decide whether or not you want to handle abstracts, whether or not you want to handle interfaces. You can filter out those individual types based on what you need. Stack traces, in our experience, or in my experience using these, it worked pretty well because the types are known to the system, while they may not be known to the developer that's using them. At runtime, the system knows about all the types because they are registered at runtime, and so it doesn't have as much of a problem with it.
Yeah, I think historically, it used to be that, like in .NET Framework, when you loaded assemblies dynamically, they got loaded in a special, I can't remember what they called it, but it's basically they didn't get loaded with the rest of your assemblies, and so they got treated a little bit differently. Although they were still, they still got run through the JIT compiler, and which effectively gives you all the stack trace information and that kind of stuff. So
we heavily use stack traces for our error handling. Catching the uncaught exceptions, just so that way we could get the very large stack traces, and we never ran into any problems with using these services, using the dynamic loading of content.
And this is all .NET Core, right?
We use .NET Standard for most of it.
Okay. Yeah.
But .NET Core does have some of this functionality as well.
Yeah, I guess I was trying to draw a distinction between framework.
Yeah.
Yeah, you weren't using framework for this, right?
Yeah, we did use .NET Framework for a lot of it.
Okay.
Yeah.
Yeah, there's some interesting things that happened there. I noticed that when .NET Core was released, I don't believe an app domain is a concept that carried through.
No.
Always made things a little bit more interesting.
Yep.
Framework.
Yep.
What other questions do we have for Stephen?
My other question there was about the refactoring. Do you have any special
Oh, yeah.
techniques for
Um,
that?
well, one of the, I mean, there were some times where we ran into issues with refactoring. Most of them involved when we had a piece of ancillary code that was being dynamically registered like this, that it ended up getting used so many times that we ended up wanting to promote it to our core system. So we had to pull it out of one of those ancillary assemblies and put it more in the heart of the system. And that, that invariably caused issues with, you have to make sure you change the namespaces and the types and all of that other stuff. But for the most part, because these processors are so disconnected from each other, we didn't have to have a lot of refactoring. For the individual content types is very, very localized. Now, if you did end up adding other properties for the attributes, or you want to register other values with these types, then yes, you could end up running into problems where you would have to touch 15 different assemblies to update that attribute, to update the interface, change your base type, which then you have to change all of your derived types. But I would say out of the 20 or so processors that we had, we only had to do that for, I think, maybe 2 or 3. So we didn't have to refactor much, which was nice. And that was over a period of about 9 years.
Cool. Thank you.
Yeah.
Anything else? All right. Well, I think that's it. Is it healthy to implement reflection since it will take a large amount of resources? I think that's an interesting question.
Yeah. I don't know. I think so. Like I said, the reflection, the big performance hit was always when the application first started. And it really wasn't that large of a performance hit, especially when you're talking about long-running services that you're usually only starting, maybe once every few weeks, once every couple of months. If it's an application that is constantly being launched, then yes, this would not be a situation where you would want to use this content, right? Because when it becomes a situation where you have to spin up an instance of this process on a regular basis, you wouldn't want to take that performance hit up front. I wouldn't say it took a lot of resources. I mean, like I said, it was about a half a second for a couple of thousand types. It was pretty fast considering everything else that was going on, spinning up database connections and initializing logging systems and all manner of things.
Yeah, that's been my experience as well. I think people make a big deal about the time frames that you experience with reflection, and if you like Stephen was saying, if you do it millions of times, yeah, it's going to cause a problem. But you can have that problem with just about everything if you're going to do it a million times.
Right.
So and there's lots of great strategies around caching that you can take advantage of with reflection as well.
Yeah. One of the to tangent off a little bit, one of the things that we toyed around with this system was we even toyed around with creating a directory watcher service. So just creating a directory watcher that would truly make this runtime compliant. So then when an assembly is dropped into a specific folder, then it would load the assembly and throw it into the registered types and run through this processing system, but we never went into doing that. The you know, for the most part, the juice wasn't worth the squeeze.
Cool. Well, I appreciate you taking the time to present for us tonight, Stephen, and
Yes.
other guys. It's been great.
Thank
Great variety of topics.
Appreciate it.
Yeah. We're very happy to have you. Yeah, I love the variety of topics tonight. There's a lot of diversity in what you guys were presenting on. So yeah, that brings us to the conclusion of the presentation part of the show, I guess.